Hey everyone, today we're going to talk about redox reactions. So, this is going to be a main focus of this unit. And so what does redox stand for? It stands for reduction and oxidation. But we just say redox for short. It's a lot more catchy. So redox involves the transfer of electrons. As you know, ionic bonding involves the transfer of electrons. But even covalent bonds move electrons around. Oxygen here attracts more electrons than carbon. Okay, so it's the gaining and loss of electrons. So why are they important? Redox reactions have several applications. So one, for purifying metals. You can produce different gases using redox reactions. You can electroplate metals. It's very important for batteries. We're going to talk about batteries towards the end of the week. It helps protect metals from corrosion, and it's also used in sensors and machines like a pH meter, which can read the pH. So yeah, tons of uses for redox reactions. So what is oxidation? Oxidation is the loss of electrons, okay? So here sodium gives up an electron to the chlorine to become sodium ion, okay? We can also see that happening in this picture here. All right, so we know that sodium with its one valence electron wants to give it to chlorine, which has 7. This is something we've learned previously. Okay, reduction is the gain of electrons. So that chlorine here is going to gain that 1 electron from sodium. So reduction is the gain of electrons. These will always occur together. Okay, so these are always going to occur together. That's why we call it redox, because reduction and oxidation occur together. So how do we remember which is which? Which one's the gain of electrons? What's the loss of electrons? One mnemonic you can use is oil rig. So oxidation is loss. That's oil, loss of electrons. Reduction is gain of electrons, or rig, oil rig. Another mnemonic you might use is Leo. And what does the Leo say? Grrr. So the loss of electrons, Le, is oxidation, or gain of electrons is reduction. Feel free to use whatever works for you. I myself prefer oil rig, but this will help you figure out which is which, okay? So you're going to get equations like this, and you're going to be asked what's being oxidized and what is being reduced. So we have to have some kind of guidelines to help us out here. So we're going to use the oxidation numbers to help us out. And so here are the steps for doing these kinds of problems. First, write the oxidation number for each atom in the chemical equation. You may want to review the rules for oxidation numbers. Then you're going to see how the atom changes from left to right. If the number decreases, then it quite literally, right, is reduced. If the number increases, then it's oxidized. So again, let's look at example 1, and we'll do this one together. So we want to write the oxidation number for each atom in this equation. So remember that any pure element, the oxidation number is simply 0. Okay? Next I have potassium in KCl. I know that any alkali metal has a oxidation number of +1. If potassium is +1, that means this chlorine has to be -1. Okay? So what is being oxidized? So remember, this means increase in number. So both of these start out at 0, but potassium is the one that goes from 0 to +1. So in this example, potassium is being oxidized. That means that chlorine is going from 0 to -1, and we say that chlorine is being reduced, or Cl2. Okay. So the chlorine is being reduced because the number is literally being reduced. It's going from 0 to -1. Versus the potassium here is going from 0 to +1. All right, let's try another example. We'll do the same thing. So again, when you get these problems, you want to assign oxidation numbers to everything. And the elements are the easiest because they are simply 0. So what chemical is being oxidized? So we have to also do the ions here. Remember, oxygen is always -2. That's one of the oxidation rules. If oxygen is -2 here, this mercury has to be +2. Remember, those numbers in an ionic compound have to cancel out. So now we want to see what's happening. Well, oxidation means the number's going up. So all these numbers are becoming 0. So from -2 to 0, that's an increase. That's going to be my O-2 ion. Okay, so this chemical here is being oxidized because it's going from -2 to 0. On the other hand, we can see, excuse me, we can see mercury going from +2 to 0. So this ion, right, starts off as +2, then it becomes reduced to 0 when it becomes a pure element. And therefore Hg+2, include the ion charge, is being reduced. All right, so follow these examples, and hopefully that'll help you figure out the rest of the practice problems on your worksheet.